Hi, this is Manish from Microsoft Research, and today I will be presenting our work on neural knowledge extraction from cloud service incidents. In the last decade, paradigm shifts such as the move from box products to services and the widespread adoption of cloud computing has reshaped the software industry. Particularly, incident management, which deals with managing unplanned interruptions or degradations of a service, has become critical to develop and operate large-scale services. As we can imagine, there are various key performance indicators associated with incident management, such as TTD or time to detect, TTE or time to engage, and TTM or time to mitigate. In regard to the key performance indicators mentioned, the ultimate goal for incident management is to reduce these TTX metrics and keep SLA, that is service level agreements. Although incident management today has become highly automated and fast, we still observe significant delays in different management phases. Particularly, we observe delays in the incident engagement phase and the mitigation phase. Thus, any improvements to the system would positively impact customers and service quality. Based on our past experience and conversations with product teams, the key insight we drew was that most customer-created incidents lack any sort of structure or schema. This makes automation of tasks such as pulling up logs or running basic health checks non-trivial. With that insight, we built SoftNER, an unsupervised knowledge extraction framework for cloud service incidents. We framed the knowledge extraction problem as a named entity recognition task. Here are some examples of entities SoftNER is able to extract from incidents. We see that SoftNER can extract critical information such as problem type, exception message, ID of the resource affected, and so on. In terms of prior work, the software engineering community has focused on incident management, particularly on aspects such as finding related incidents, incident triage, and recommending mitigation steps for incidents. Whereas, in the systems community, a lot of recent work has focused on diagnosis of incidents, such as root causing, bug localization, log analysis, and so on. In the information retrieval community, data extraction has been widely studied. Snorkel is one such interesting work from Stanford. It focuses on using weak supervision and noisy heuristics for automated data labeling, which can then be combined with supervised machine learning models for data extraction. Something to ponder over here is why we need a new framework like SoftNER for data extraction, or why we can't use existing frameworks in the incident management space. Let's answer that by analyzing some unique aspects of DevOps artifacts. Firstly, unlike the web space, where we have a fixed set of entity types such as people or places, the incident space has large sets of varying entities. This is mainly due to hundreds of services and organizations within a company like Microsoft, each having their own vocabulary. For instance, the host OS team in Azure is interested in entities such as the instance name, Hyper-V error, and fault code. On the other hand, Azure Networking would look for entities such as Virtual Networking ID, Destination IP, and so on. Secondly, given that there is such a large varying set of entities, it becomes infeasible to obtain label data to train machine learning models. Lastly, unlike the web corpus, we also have a rich set of types embedded with natural language such as error code, stack traces, and IP addresses. Keeping those aspects and insights in mind, we built the SoftNER machine learning pipeline. Here is an overview. We first start by collecting a large dataset of incident reports from the incident warehouse. We then perform standard data cleaning and pre-processing techniques such as cleaning of HTML, segmentation, and tokenization. We then move on to unsupervised data labeling. As highlighted before, in our scenario, we don't have a prior set of entities or label data. So we leverage syntactic patterns such as key value pairs and tables to infer entity types and also create label data. For instance, in the example shown, we see that using the key value pattern, company name, forest, and tenant ID are recognized as entity types, and their corresponding values are labeled. Note that we also tag each value with their data type. For instance, the tenant ID mentioned would be tagged as a GUID. Following that, we also generalize the labels beyond these syntactic patterns by leveraging label propagation. In this approach, we propagate the labels of tagged values to other untagged instances where the syntactic patterns might not match. With this labeled data, we train a supervised machine learning model for entity extraction. Here is the architecture of our named entity recognition model. We make use of multitask learning to train a BiLSTM-CRF model on two complementary tasks, entity type prediction and data type prediction. We find that using data type prediction as a complementary task for NER, the performance of the model is significantly improved. To evaluate our approach, we looked at different aspects of the pipeline. Firstly, we evaluate the precision of SoftNER in inferring entity types. Since we lack any prior knowledge about the types of entities, we manually evaluated the top 100 frequent entity types. We find that our approach has a high precision of 0.96 at rank 50. We also compared our multitask SoftNER model against various baselines such as BiLSTM-CRF and BiLSTM-CRF with attention. We see that by incorporating data type information, we're able to beat these state-of-the-art models with an average F1 as high as 0.96. Lastly, one of our main goals with SoftNER was to help downstream tasks such as triaging and mitigation. We thus attempted to build triaging models that leverage raw incident descriptions and also SoftNER's output. We observed that using SoftNER extracted entities as features leads to significant gains in accuracies for triaging. In terms of future work, we are working on expanding SoftNER to other artifacts such as troubleshooting guides. We're also working on enabling health checks using SoftNER entities and improving tooling. Lastly, we're exploring related ideas such as relation extraction and entity linking. To summarize, DevOps artifacts like incident reports and customer tickets are unstructured, making any kind of automation non-trivial. We have built SoftNER, a framework for knowledge extraction from such incident reports. SoftNER has been integrated into the incident management platform at Microsoft. We are currently working on expanding SoftNER to other DevOps artifacts like troubleshooting guides. Thank you.
Hi everyone again. We are back here with the second presentation of the Monitoring Cloud-Based Services session. And we have one of the authors of this second presentation, Manish Shetty. Waiting for questions from the audience. Please start typing your questions on the chat on the right hand. Meanwhile, Manish, while people are typing their questions, I have a question for you. In terms of the knowledge that is extracted using your approach, can that knowledge can be also used for other activities or other tasks apart from triaging? Have you considered that?
Yep, yeah, that's a great question. So we have been kind of utilizing this, at least trying to do that in the future. But currently we're trying to use this information, like the entities that we are extracting, to kind of improve the tooling that goes behind incident management. For example, basically there are forms which customers fill in, wherein they write the information about a particular incident. But then what we can actually do with such entities is we can map which entity is kind of important to a particular kind of incident, and then use them as mandatory positions in the form. So the customer doesn't have to think about what to fill in the form, directly fill in. Let's say, for example, we require a resource ID or an IP address. If there's a particular form there, they can just fill that, right? So, and that's been one application, and we've also been like working with product teams in Microsoft who can like consume these entities and use it like for root causing or for other kinds of activities.
Okay, good. Thank you. And I think we have now our first question from the audience as well, from Heng Li. Heng Li said, interesting work. I'm curious, what's the accuracy of the semi-supervised labeling, and how does the performance of the model hold over time when new incidents come?
Right. Yeah. Great question. Thank you. And yeah, to answer the first part, the accuracy of the semi-supervised labeling. So basically, since it's semi-supervised, or I should say, the way we've written in the paper, unsupervised, because we don't have any label data at all. The way we evaluate it is basically using a manual evaluation method where we look at like the top 150 to 100, 100 to 150 most frequent entities occurring or being extracted by our framework, and validate whether they're actually important entities or valid entities. And we then basically mark its precision, right? And to answer like the actual accuracy, the precision at rank 50 is 96%, and at about 100, it's close to 77 to 78%. And how does the performance of one? Yep. So the second part of the question, again, great question. So this particular thing is a work in progress since we've just deployed it, and we're trying to get feedback from the users. So this is something we're continuing to work on, but we don't have any particular numbers as such.
Okay, thank you. Okay, let's see if more questions will come up. Manish, have you considered a more proactive approach to be incorporated into your incident management that could help with incident management?
Could you tell me by proactive, what do you mean by proactive?
Like predicting and being more proactive instead of acting after the incident, but
yes,
trying to avoid
the incident. Got it. Yeah. So I think this particular problem was trying to basically complement all the other things that we've been doing in incident management, which is basically, like you said, incident diagnosis and like you said, proactive approaches, which can kind of predict that an incident is going to happen. This one is more like towards the mitigation phases in the incident. So that we found as a very large like a time-taking process in a large like company or like a service provider like Microsoft, and yeah, to basically complement the work that incident diagnosis and incident management has like kind of like developed over the years. We went and like looked at what's the key problem in incident mitigation, and that's where we found that, you know, the incidents are really verbose, and like engineers have to kind of look through that verbose statement to find actually what the issue is, and that's where the pain point was, and that's what we were trying to solve. Yeah.
Okay, good. Thank you. Just to remind people that after the session, we'll also have a discussion room where people can join and continue a more sort of face-to-face interaction with Manish.
Yeah.
For those that are interested. So let's see if there are more questions coming. Okay. Audience a bit quiet. If you want to complement anything, Manish, from the presentation, please feel free while we wait for questions. There is anything you'd like to discuss in terms of future work or?
Yeah, so I think I just mentioned, like in your previous question, that we're basically we're still working on that improving tooling thing. And another kind of branch from this work that we're looking at is not just looking at named entities, but also kind of the relations between these entities. For instance, like it'll be really useful for an engineer to kind of identify that a particular IP address and a particular resource ID are mapping are or belong to the same system, or they point to the same system. And those kinds of relations between entities is something we're exploring in as future work. Yeah.
Okay. Good. Yeah, I don't know if you have a chance of looking at the papers from your session, but they are quite related, the three of them. Not surprising though. Yeah. And perhaps the authors should get together and discuss a little bit more.
Definitely, yeah.
Yes, it's okay. Okay, no more questions. So Heng Li is asking if there is any data public data related to their work.
I don't think there's anything public out there already, and for like obvious like Microsoft reasons, since the data is confidential, we won't be releasing it. But we do plan to release. At least we're trying to work towards releasing the code, and we were working through compliances and stuff. And once we like get through that, we'll be putting up the link on the archive version, so you can find the code there. Yeah.
Okay, thank you. So I think I'll take this opportunity to thank you for joining us in this session, and congratulations for your paper.
Thank you.
And hopefully you can join the discussion room and they will have more debate or discussions there.
Yeah, thank you.
Thank you, all the best. And